In this series, we're going to look at P3, and the topic that we shall be focusing on this particular time is the topic of modulus functions, whereby we shall really look at on how you are supposed to approach different questions as far as modulus function is concerned. So one of the areas that you'll be asked in modulus function is to identify the vertex. So in the event you are given an equation with y modulus ax plus b, it means for you to obtain the vertex, for you to find the coordinate of the vertex, it means that the x coordinate is going to be negative b over a. Negative b over a, which means that you are going to check what is the value of b here. You write it negative over the value of a, that is in this case. So the case scenario of that is whereby you are given this particular expression here. We are having 2x minus 1. To find the vertex, to find the coordinate where this graph is going to turn up, because a modulus function or any modulus function, they don't have negative values. So the vertex is going to be negative of negative 1. Negative of negative 1 is positive. So which means this is going to translate to 1 over 2 comma 0. So the coordinate is going to be what? 1 over 2 comma 0, like that. So this becomes the coordinate of this point that we have here. So whenever you are having equations like for graphing y is equals to modulus of x, so if you are given the function y is equals to f of x, so what you need to remember, if you are going to find the modulus of the entire function, you are going to reflect on the x-axis. So for instance, if you are having part of the graph here that is moving down like that, this point that you have at this point here, this graph was to continue up to this point. So which means this point that you have here will be reflected on the x-axis. Of course, you need to remember that this is our x-axis. So which means if you reflect this part of the line up, it's going to become this section of the line that we are having at this point here. Okay, so there is no way you are going to have negative value for modulus functions. If you are supposed to find f modulus of x, meaning only x is in the modulus, it means this is a reflection on the y-axis. This is a reflection on the y-axis. So all the points which are on the right will be reflected on the other side. Now, solving equation inequality. Now we're going to use the graph of this to solve this one. Using the graph of y equals to 2x minus 1 to solve 2x minus 1 is equals to x plus 5. So whatever you need to do when you're given a question like this is that in order to find the solution using the graph, you are going to plot the graph of x plus 5 also on this same grid. So once you have drawn that on the same grid, next you are going to check where are they intersecting. What is the point of intersection of the two? Then you are going to read your values down below here. You shall read them right down below here for you to be able to work it out. So if you are using graph you have a modulus function and a linear graph, it means you are going to have the modulus function and on the same graph plot the graph y equals to x plus 5, and you check where the two are intersecting in order for you to get the answer for that. But how do you use graph to solve 2x minus 1 modulus greater than x plus 5? How do you use your graph to do that? First, you are going to, as we have mentioned, you are going to have the modulus function is this one here. This is the modulus function. This is this one here is the modulus function. This one. You can see this. This is the function y. This is the graph y is equals to 2x minus 1 modulus. And this other line here, you see here, this is the line, this other line that we are having here. Let me just color code it differently so that you can be able to see. This one here, this represents the line y is equals to x plus 5. But remember, we are supposed to use, you are supposed to use the graph in order to find the solution. You are finding where 2x minus 1, which is this modulus function here, is greater than y is greater than x plus 5. So where is the modulus function above the straight line that we have drawn? The modulus function is above this line in different instances. At this instance, this is where it's above the line, and also in this instance here, it's above the line. So whenever we are going to state the solution for this, we are going to state regions where that graph is above the straight line. So that means our solution is going to be stated as follows. You can see where they are meeting here is 6, isn't it? So this solution must be, it must be x is greater than 6, because for x greater than 6 in this side here, the graph is always above the line. And also where they're meeting here is -4/3, but values below this that is where the graph is above, this modulus function is above the line, then we are going to say also x is less than -4/3, and now that becomes the solution of this. So the next bit is the use of algebra. How can you be able to use algebra in order to find this kind of a question where you are told find the value of x for which satisfy this equation 2x minus 1 modulus is greater than x plus 5. How do you work it out using algebra without using this particular graph? Already I've shown you how you can be able to use the graph. But this one now, remember modulus mean this part that we are having inside here, this part that we are having inside here can be positive or negative, because if we were having the modulus, it means if it was negative, the result is taken to be positive. So for that case, you are going to take the first case scenario. The first case scenario will be 2x minus 1 considered being a positive, we are going to say is greater than 5. Then you are going to take 1 on the other side, you bring x on this side, then you shall have 2 minus x will be x, 5 plus 1 will be 6. So one of the solution will be x is greater than 6. The solution that we ideally got at this particular point, right? Then the second bit of it we are going to do is when we shall be taking whatever that is inside the modulus to be what? To be negative. So we are going to say we shall take whatever that is inside the modulus, we shall take it to be negative, and then we shall say is greater than that. So we shall have negative 2. When this x comes on this side, it becomes negative, so it be negative 2 minus negative 1x is going to be minus 3x greater than 4. And when you simplify, you shall get divide by negative 3 divided by negative 3. So you see the sign is facing this direction. But if you divide by a negative, the sign switches off. So that's why you can see the sign now is facing backwards. And that's why we got our answer like this. So you can see using algebra, you can be able to really get the answer correct. Another method you can be able to use here is the use of squaring. You can be able to remove the modulus and then you square. Let me just show you how you can go about that. Now, for instance, let's say, yeah, it's algebra, but now this is a different approach. Let me just show you what you can do. So you see you are having 2x minus 1, x plus 5 in this case. Then what to do here, you are going to remove the modulus, this modulus here. You can remove it by squaring, and that's going to be 2x minus 1. We square whatever that is on the left hand side, and also we shall square x plus 5, which is on the right hand side. Then in that case, we're going to put the like terms together. And then if you square this will be 2x squared will be 4x squared. This times 2x times 1 times 2 will be minus 4x. 1 squared negative, it will be positive 1 is greater than. This is going to be x squared plus 10x plus 25. So that is how we're going to expand that. Then we're going to put the like terms. So it will be 3x squared. We bring this here, it will be minus 14x, and this will be minus 24 is greater than 0. So which means at this given point, we need to go ahead and solve this particular quadratic equation. And we can be able to say this is going to be, if we solve this, it will be x 3x squared minus 14x minus 24 is equals to 0. Anytime you are solving equation to do with inequalities, what you need to remember is that you need to assume that was an equal sign so that you can be able to find the critical values. Yeah, so we shall treat this inequality as an equal sign first to enable us to solve. And for my x is going to be 14 plus or minus square root of minus 14 squared minus 4 times a, which is 3 times c, which is negative 24. Then divide by 2a. And if I work out this, 2a, 2 is times 3, so I don't have to write 2a times 3. So if I can put this in the calculator direct, so that we can be able to get the answer, the quadratic here, our quadratic here is 3. Then we have negative 14. Then we have negative 24. So the first solution you can see here, our value of x is going to be 6, or x is equals to negative 4 over 3. But now you cannot leave your answer at this particular point. How do you write the answer now? You are going to draw a line. Because this was a quadratic, it will open upwards. It will be a quadratic that is opening upwards. Yeah, why is it opening upwards? It's because the coefficient of x here is a positive value. Then in that way, we shall have this and this at this point. So meaning that we can identify, for us to state the exact values here, this is going to be minus 4 over 3, and this is going to be 6. Which region of the graph do we want? Greater than. You are told greater than. So if it's greater than, you need the section of the line of the graph that is above here. and you need this section that is above, not below the line. This below the line means less than, but if you were told greater than, you need the region above the line. Which values of x will give you the graph that is above the line? Values from here onward will be giving you values above the line, and also values from here in this direction will give you values of the graph above the line. So which means our answers should be stated: values of x less than -4 and values of x -4/3 and values of x greater than that. So our final solution will be x is less than -4/3 strictly, and x is greater than 6. Yeah, so those are now the solution for this particular question. So in P3 also, you are going to be seeing questions whereby you are supposed to state the coordinates after the transformation. For instance, we are told here the points P, -4, -3 lies on the curve with the equation f of x, where x is a member of a real number. Then find the point to which P is mapped to when the curve with the equation fx is transformed by the curve by the transformation whose equation is this. So we are having y is equals to 2x. This transformation is only affecting x values because it's done inside the bracket. So this is 2x. So which means only the x coordinate here will be affected. Yeah, only the x coordinate will be affected there. So for you to get this coordinate after the transformation in part A, it will be, and whenever you are having a transformation inside the bracket, it does opposite of the transformation that you are being told. For instance, if you are told 2x, this is the same as 2 times x, but when you are going to write the answer here, it will be -4 divided by 2. You are not going to multiply. You usually do the opposite. If you are told multiply, you divide. If you are told add, you subtract. So this one here, for A, y coordinate will not be affected. The only part that will be affected is the x coordinate. So it will be -4 divided by 2. That's going to be -2, and the coordinate remains like that. So it will be -2, -3. The y coordinate is not going to be affected because whatever transformation is happening inside the bracket. For 3fx minus 1, inside the bracket we have a transformation, which is subtraction, which means also that -4 is going to be added. We are going to add 1. Here they are telling you subtract, but when you are finding that coordinate, you do the opposite. So it will be -4 plus 1, which will be -3. So that coordinate will be -3 for the x coordinate. For the y coordinate, there is a transformation outside the bracket, which is 3. So this transformation only affects the y value, which means it's going to be 3 times -3, and that's going to be -9 there. When you are told modulus, modulus is going to affect only the y value, and if it's a negative, it becomes a positive. So that is -3. It's going to be -4, 3. Only the y coordinate is affected by this modulus. So that's exactly what you are supposed to do in that case. Let's look at a scenario whereby you are given the figure and then they want you to find the coordinate of the y coordinate. They want you to find the y coordinate of A. How are you going to go about that? The y coordinate of A. Now, remember, at the y coordinate, y-intercept, x is always equals to 0. So in order to work it out, the y-intercept at this point we are going to go to the original function, and the function is f of x is equals to modulus kx minus 9 minus 2. Then you can see now we are finding the y-intercept here. It means at the y-intercept x is equals to 0 here. Then it means we are going to substitute it there, and that's going to be f of x is going to be equals to modulus k times 0 minus 2, no, minus 9, then minus 2. Yeah, I don't want you to confuse this as a modulus. This one, I'm just separating these two steps. From this one, we move to the next step. So, therefore, our f of x is going to be what? 0 minus 9. But since this is a modulus of negative 9, it will be 9 minus 2, and that answer is going to be 7. 7 is going to be the answer in that particular case. To find in terms of k the x coordinate, what do we say? How do you find x coordinate? You are going to say negative x coordinate is going to be negative of b over a, which is going to be negative of negative 9 here over negative of negative 9 over k, and therefore this answer is going to translate to be 9 over k as the coordinate of x coordinate. We had used this relation I told you, vertex negative b over a comma k, where you have your k is here, okay, negative b over the value of a over and then k. Now this becomes the vertex, this coordinate here. But if you want the x coordinate only, you'll do x coordinate only for the vertex is going to be negative b over a. So that's why you can see I'm purely taking negative of negative 9 over k, and that's giving us that. Now we're supposed to find the range of values there. We are supposed to find in terms of k the range of values of x that satisfy the inequality. How are you going to work out this? In order to work out this, you need to remember that the modulus means that whatever that is inside the modulus function could be a negative or positive. So we can take this as positive, and then we're going to say k x minus 9 minus 2 is less than 0. So we can take this is going to be kx minus 11 is less than 0. Then we can take this on the other side, kx is less than 11. Then we can divide by k. Yeah, so x is going to be less than k, x is less than 11 over k. Yeah, so that's one over the solution. And the other one, we are going to take whatever that is in modulus is negative, so we can say negative into kx minus 9 minus 2 is less than 0. Then taking on the other side, we shall have negative kx plus 9 minus 2 less than 0. So that means what? We shall have negative kx is the same as what? Is plus 7 is less than 0. So we can take this on the other side to be negative kx is less than negative 7. Divide by negative k, divide by negative k. So whenever you divide a negative number, the inequality will switch the sign. So it will be x is greater than 7 over k. And those are the values. And therefore, we can now say x is going to be greater than 7 over k and x is less than 11 over k. Now once you have written this, it means this is the final answer you will give to the examiner. You will tell the examiner, Mr. Examiner, yes, I want to earn all my marks. For I to get a star, then just take that as my final answer. Yeah, so basically that's exactly what you are going to do. And in the event you are given, you are told that given that the line y equals to 3x minus 2, y equals to 3 minus 2x intersect the graph of y equals to f of x in two distinct points, find the range of values of k for that to happen. So this is the graph we are talking about. Then you can be able to sketch the graph of y is equals to 3 minus 2x. That graph possibly will run like that. So there are 2 points where this graph is going to intersect, and that is now what it means by two distinct points. It's going to intersect here, so it will have two distinct solutions. But for you to find the range of values of x in this case, what you are going to do, you are going to equate the equation, the two equations, and then you are going to square both sides in order to remove the modular sign. Once you have squared, you are going to form a quadratic equation, and this quadratic equation will be in terms of k. Yeah, so this is going to be a quadratic equation which is in terms of k. So this is going to be here, this is x squared. No, this is so that's okay. So that is okay, 10 minus that. Yeah, then we have squared. Yeah, there is a squared there. I don't know why I wanted to remove it, but it's okay, because if it has two distinct points, we are going to use the concept that the discriminant is greater than 0. And how do you get the discriminant? A discriminant is obtained by b squared minus 4ac. Our b is this, our a is this, and our c is this. So this is our a, our b, and our c. So if we substitute them here, we are going to expand and have our quadratic inequality being here. So in order to find the critical points, we are going to treat this inequality as an equal sign so that we can be able to solve this equation, and our k will be 3.6. So I want to remind you that if you want to know the solution for this, you are going to do what? To use this shape here. So we realize that this has only one solution here, so it means this is 3.6 here. So we are going to take the value on this end, which is 3.6. k is greater than 3.6. k is greater than 3.6, like that. So if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And also, if you are new here, you need to join our Patreon page. Check the link in the description so that you can be able to access this particular PDF that I usually have in my channel. All the best. Good luck in your particular exam.